तो हेलो एवरीवन, वेलकम टू द क्लास गाइस। आज मैं जो पढ़ने वाला हूँ, हम लोग जो पढ़ाई करने वाले हैं, दैट कॉन्सेप्ट इज रे ऑप्टिक्स, राइट। वी विल बी कवरिंग द रे ऑप्टिक्स फॉर एयरपोर्ट्स अथॉरिटी ऑफ इंडिया एयर ट्रैफिक कंट्रोलर एग्जामिनेशन, स्पेशली फोकसिंग दिस एग्जामिनेशन, राइट। So, see, we have seen till now that what is the ray optics? Ray optics means basically light optics. We are just going to study about the light optics. So, what first question comes into the mind? Ki what is light? What is light? You have seen so many types of waves, right? You may have seen. So electromagnetic, one of them is electromagnetic wave, right? So first you just consider EM wave. Light wave yani ray is a EM wave, electromagnetic wave. Electromagnetic wave, it means you know that let me just go one by one. Electromagnetic wave of 400 nanometer, 400 nanometer to 750 nanometer is called light ray. So what does it mean? Electromagnetic wave of wavelength, this is what? This is wavelength, right? Electromagnetic wave of wavelength 400 nanometer to 750 nanometer is known as light ray. And you all know that electromagnetic wave, light can travel from sun to earth. It means it don't need medium. So electromagnetic light waves in the same way don't need medium, and it don't need mediums mean it is a non-mechanical wave. Whereas you know that sound is a mechanical wave because in the vacuum you can't speak, right? But light wave is a non-mechanical wave because it don't need medium. Right, non-mechanical wave. Also, sound wave is a longitudinal wave, but electromagnetic, this wave of light wave is transverse wave in nature. Matlab it travels in the form of crest and trough, and longitudinal waves travels in the form of compression and rarefaction. It is a transverse wave. So this is very important thing, and sometime it comes also in the picture that 1 angstrom is equal to 1 nanometer is equal to 10 angstrom, right? So you can say that 400 nanometer, matlab it will become what? 4000 angstrom to 7500 angstrom. This is the wavelength of the light. So this is a very important thing which you should know, right? Now, in the optics, in the wave optics, you will study more in more detail. Light has dual nature. You will study it in detail. It has dual nature. It has particle nature also, right? And it has wave nature also. It is dual wave, right? I have just written everything so that I can tell you in the concise format, right? Without getting deviated too much. So, what is see, I'll tell you one very important thing. There have been a corpuscular theory which I will tell you in the optics in wave optics in more detail. So what is the ray of light, right? What is the ray of light? Hence let us try to understand clearly. Ray of light. What is the ray of light? So ray of light is the motion of corpuscles. Motion of corpuscles. What is the corpuscle? Corpuscles are very small elastic, very small particles, right? And initially it was considered that light is made up of some corpuscles, which is a particle, right? So motion of corpuscles means कुछ लोगों ने ये क्या बोलते हैं तर्क रखा कि अगर कॉर्पसल्स है, अगर लाइट वेव है, अगर लाइट पार्टिकल है, तो हम लोग कमरे में बैठते हैं और इतनी सारी लाइट हमारे सरों पे आके पड़ती है तो सर हमारा फट जाना चाहिए, राइट? पार्टिकल्स गिर रहे हैं, दिस इज जस्ट फनी वे, मतलब हमारा सर पे इतने सारे पार्टिकल्स पड़ रहे हैं, तो that lead us to a new discussion that whether light has some another nature also or not. So later it was proved that it is wave also, but no one can deny anything, No one can deny that. No one can say light is not particle because it follows all the properties of particle, and no one can say that light is not wave because light follows all the properties of wave. So light basically follows a dual nature, that is light, particle and wave. So initially we will consider, and what is the corpuscular theory I will discuss in detail. So basically corpuscular theory was proposed by Descartes. Proposed by Descartes, and Newton has finally developed it. In wave optics we will discuss it in detail, right? Newton developed it. This theory you need to remember. Okay, this theory you need to, guys, just there is some disturbance outside, let me just check it out. Okay, so this was the theory that proposed by Descartes, and Newton has developed it. Okay, let us move to the next concept. What is the ray of light? Now the concept is, when ray of light travels, there is some images formation is there, right? So sometimes you can say there is some real image. What is the real image? Real image is when two reflected rays intersect each other. Two reflected rays intersect each other. Image is formed when two rays intersect each other, right? And the important thing is, real image can be obtained on the screen. These are the subjective questions which can be asked, right? Can be obtained on the screen. Can be obtained on the screen. Now what is virtual image? What is virtual image? So virtual image is cannot be obtained on the screen, can't be obtained on the screen, they cannot be obtained on the screen. Second thing is, uh, two reflected rays appear to intersect each other. They don't really intersect each other. Matlab the light will be, the reflected ray will be of diverging nature, like this. So if this is the reflected ray, so you may assume that they are intersecting here, but they are actually not intersecting. But in the real image, the intersecting rays will be of this nature, like this one is coming here and this one is going here. So they will really intersect each other. Okay, so this is your real image and virtual image. Now the next concept is number of images, right? Or I will say, let us discuss about the mirrors also. Here I haven't written, but this is a very important thing I should tell you. Let us discuss about the mirrors, right? Mirror is very important concept. So mirror may you first study plane mirror. Right, you first study plane mirror. So plane mirror is a mirror which is very, you can say it is very like this, like you have seen plane mirrors, the normal glass which you use to see the faces, that's all. They are the plane mirrors, right? So plane mirror is what? Matlab there is a normal mirror and you just polish it by silver. Silver polish is there in one side, then it becomes a mirror. Normal glass को हमने एक साइड पे क्या किया, सिल्वर से पॉलिश कर दिया, तो ये बन जाता है आपका प्लेन मिरर, राइट? सो प्लेन मिरर में यू नो दैट लाइट का, लेट्स से अगर लाइट इधर ऐसे इट कमिंग लाइक दिस, then it will reflect the angle, what is the basic rule of reflection, fundamental law of reflection? So I will say laws of reflection. Laws of reflection is first that incident ray normal and reflected ray all are coincident at point of incidence, right? So they three are coincident, matlab they are coincident at the point of incidence. It means, let's say you are, this is the mirror. So let's say an array of light is incident here. Let's say it is incidenting here. So it will incident here. This will be known as point of incidence. So there can be a normal here. Then reflected ray will be like this. So they all will meet here. Correct? Second law. Second law is, you all know that angle of incidence is equal to angle of reflection. So what is the angle of incidence? Angle of incidence is the angle between incidence ray and the normal. So this will be angle I, and angle of reflection is the angle between incidence ray and the reflected ray, that is R. So the law of reflection says angle I is equal to angle R. Angle I is equal to angle R. Okay. Now this is you people, many people knows it, but many people doesn't know it. This angle, what is the, what do we say this angle? This angle is basically glancing angle, right? This angle is glancing angle. So this is theta and this is also theta. So both glancing angles are equal. Okay. So this is the glancing angle. So this is the laws of reflection. So in plane mirror, the image formation is what type of image formation? See, image formation in plane mirror. Image formation in plane mirror. Okay, image formation in plane mirror. So number one, what can be the type of plane mirror? Just simply like let's say this is the mirror. Okay, so let's say this is the horizontal line, and suppose one object AB is kept here. This is A, this is B. So you know, let's say one line is, this line is coming here. Let's say this is the incident ray falling here. So the angle of incidence will be what? It will be 0, because normal is also like this here. So angle of incidence is 0, so angle of reflection will also be 0. So means the reflected ray will be traveling the same direction. So we have one common rule: light falling perpendicularly on the mirror retraces its path. It comes back in the same, following the same path. Now suppose another thing is, let's say this light is coming here. Okay. So here we will make normal. This is the angle of incidence. So same angle of reflection, the light will come here. So now see, very important thing. What happens? This is the angle of light. This is the one reflected ray. This is another reflected ray, and they are diverging in nature. This is going this direction, and this ray is going in this direction. So you tell me, they will intersect each other? They will intersect or not? So they are diverging in nature. It means they will never intersect. So what happens? It appears, someone, let's say, standing here, it appears that both rays are coming from this point, right? It appears that both rays are coming at this point. So basically at this point of intersection, the image of point A will be formed. The point image of point A, matlab this will form, that is A dash will form here. Similarly, this point, let's say this is some point, so its image will be forming here, its image will be forming here. So similarly, this bottom point B will be forming here. So when you will join, you will get an image, that is B dash. So important thing is here, the nature of image formed by plane mirror. So I can say that image formed in plane mirror is, number one, behind the mirror. Behind the mirror. Now tell me, this is real image or virtual image? So basically this is virtual image. Virtual image is formed. Number third, virtual image is formed. After that, uh, erect image is formed. Erect means seedha, right? Inverted means ulta. So erect image is formed. Number fourth, at the same distance, at the same distance means this, let's say this is the distance of image, this is distance of object and mirror is d, then distance of mirror and image will also be d. So at the same distance, erect virtual image, erect image behind the mirror at the same distance. Now second thing is, what is the magnification? So just let me tell you, linear magnification. Linear magnification, right? There is a concept, linear magnification. This is equal to m is equal to I upon O, where I is size of image and O is size of object, right? So if it is in the we just follow the same rule, like this is, let's say, origin, so the above one will be taken as positive, below one will be taken as negative. So here the image and object both are inverted, so both are positive, so you can say size is also the same, so magnification will be plus 1. Magnification will be plus 1. If the image is inverted, then magnification would have been minus 1, but here the magnification is plus 1. So this is a very very important concept for the okay, this is virtual image. Virtual image means cannot be obtained on the screen. Can't be. Let's say question is the image formed by plane mirror is, number one option, can be obtained on the screen. Number two is inverted. Number three, uh, cannot be obtained on the screen. Number four, magnification is minus 1. So you can simply select the option that the plane mirror image is something which cannot be obtained on the screen. Cannot be obtained on the screen. So this is the image formation in plane mirror, right? Now we will be discussing about the spherical mirrors and all, right? See, this is, let's say, spherical mirror. Okay. So spherical mirror, let's say you have a spherical glass like this, right? It can be in the form of spherical glass. मतलब it is a not circle, it is a sphere. So let's say you cut a portion. Let's say you cut a portion, this one. So the a mirror will be of this shape, right? It will not be a line. It will be of this shape. So let's say mirror is formed like this. This is the, sorry, glass. Now you have two options, because to make mirror you will have to polish with silver at one end. There is some other options also to polish, whether it is silver or some other thing. Just check it out, right? What is the exact material which you used for polish? That is made of silver, which I know, remember, right? So there's two things. This is the portion which is cavity end, कहते हैं दांतों में cavity है, and this is the convex portion. So if you polish the convex portion and your reflection is happening at the concave cavity wala portion, then this mirror becomes concave mirror. Concave mirror. And if you polish the concavity, if you polish the cavity, then your reflection appears at the other end, so this mirror becomes convex mirror. Convex mirror. The sphere which we have, from where we have cut the sphere is no, let's say it has the radius r, so this will also have the radius r, this will also have the radius r, and this will be known as, r is known as radius of curvature. The radius of curvature. Let me just confirm it, where concave and convex mirror. Concave mirror, एक minute. Concave mirror. It's not, maybe internet is weak here, I think. Anyway, I think I have connected this with laptop, so that's why. Okay, it's correct, yeah. It's correct, okay. So this is the spherical mirror. Now we'll understand the basic laws of reflection in the concave mirror. So number one thing is all the rays coming let us see it one by one. Let's say this is the mirror. Let's say this is the mirror. This is, let's say, center. So this will be known as axis, principal axis. This line is known as principal axis. C is center of curvature. Okay. The point, the where axis and mirror meets, this is known as pole. And the middle point of the pole and center of curvature is known as F. So this is basically focus. This is basically focus. So the rule, law of same thing will be applied in the your concave mirror also. So laws of reflection in spherical mirror. Number one, laws of reflection in spherical mirror. Number one, all the rays coming parallel to principal axis will pass or appear to pass through focus. What does it mean? See, let's say this is the mirror, this is the axis, a ray of light is coming this way. So after reflection, it will pass through focus this way. Actually, here also the laws of reflection is followed. Like this is, let's say, center. So this will be normal. You know, this will be normal. So angle of incidence will be angle of reflection. The same thing is followed here also. Let's say this is the convex mirror. Either in this direction this is followed. So here what will happen? Let's say a light of rays coming like this one. So here your normal will be this one, because perpendicular at any point of contact, perpendicular rate circumference always passes through center. So this is the center of curvature. So here this is the normal. So light would try to pass this way. So actually it will pass through this focus. It will appear that it is passing through focus, right? So it will appear that it is passing through focus. So after reflection it will go this way. So this is first thing. Second thing is a light of ray incident on pole simply follows law of reflection. Law of reflection, what does it mean? It simply means, let's say you have this mirror, you have this mirror, and this is the pole. So a light ray, let's say, incidenting here. It says incidenting here. Okay, so after reflection it will simply follow, let's say, angle of incidence, so it will follow the same angle of reflection. The reflected ray will come like this. So this is your this one. So this is the mirror, right? This is your mirror. Okay, Third law is light of ray passing through C retraces its path. Retraces its path means a light of ray which is coming this way. Let's say this is this one, this is center of curvature. So light of ray, this is passing through this one, simply comes back in the same way. Why? You can also understand it in this way. Let's say this is the light, this is the mirror, this is the center of curvature. So let's say a light of ray is going from here. So you know when you will be drawing the normal, so normal is always passing through the center on any circle, right? So normal will be the same this one. So angle of incidence is 0, so angle of reflection will also be 0. So it means it will come back, reverse, come back in the same, following the same path, right? So that's why it retraces its path. This is the basic law of reflection in the spherical mirror. Now coming to the image formation by spherical mirror, by convex mirror and concave mirror. So first thing I will write image formation by concave mirror. Okay, see this one. I want to actually I want to take the uh, blue background. Anyway, I'll take it. I'll be taking it later. See now. So let's say I'll write image formation by concave mirror. Okay, image formation by concave mirror. Number one, let's say this is a concave mirror. So number one, when the image is at infinity, image is at infinity. So let's say this is the principal axis. So at infinity means it is at a far distance. So at a far distance, when the mirror is at far distance, it means any ray of light will come. It will appear that it is coming as a parallel to principal axis. So anything is coming here. After reflection, it will pass through focus. So it will be center of curvature. This is focus. So after reflection, it will pass through this one. Anything coming parallel, any ray will be coming, that will be parallel. So it will come here and it will go like this. So they are really intersecting here, and but all the reflected ray will be intersecting at focus, means image will be number one at focus. Size is what? It is a point image. It is point image. Number third, location at focus, point image, real image, right? Number four, magnification, I upon O, size of image is 0, so therefore it will be tending to 0. If it is let's say this has a very small width also, so that small size of the image also, but magnification will be tending to 0. Okay, magnification will be tending to 0. So this will be m is equal to I upon O, which is tending to 0. So this is the first image formation by spherical mirror. Second thing, let's say your object is at not at infinity, it is in between, like this one. Let's say this is your focus, this is your center of curvature, the image is in between infinity and C. So let's say image is this way. So what will happen? A light of ray will go this way, it will pass through focus, right? It will pass through focus this way. Let's say a light of ray is coming like this. Okay, so it will pass through this way. So image will be, see the top, this point has been, this image has been formed here. So this will be here, similarly this way. So image which is formed in this case will be what? At between center and focus. Second, diminished or enlarged? Diminished मतलब size means छोटा, diminished, size has been decreased. Third, inverted image, inverted image, right? Fourth, real image, yes, really intersecting, real image. And magnification will be less than 1 in the negative direction, right? Magnification will be less than 1 because size is small. So basically it will be in the minus 1, right? So you can say magnification will be less than 0 but greater than minus 1 in this case. Okay, moving to the this one, third case. Image is at C. So this is your mirror, this is center of curvature, sorry, object is at C, what I am writing. This is your image, this is pole, so this is center of curvature, this is your focus. So this will be your image, oh sorry, object. Object is at C, so light will come here, it will pass through focus this way, and anything, acha, light coming from focus after reflection it will become parallel. So it means coming to focus it will become like this one. So after reflection the image will be at the focus. Image here will be at focus. Size will be same size. Same size means magnification will be minus 1. Third will be at, sorry, what is the focus? At center of curvature, na, at C. Inverted real image, right? So this is the nature of image formed by spherical mirror in this case. Number 4, see there. So number 4 is when your object is between C and F. So you can see your object is moving in this direction and image is shifting in this direction. So let's say this is F, this is C, and here is your object. So this will come here, after reflection it will pass through focus, and let's say this is coming through focus, after reflection it will go like this. So we will see this is the image, right? So image is enlarged, bigger in size, enlarged, inverted, real image, magnification is greater than 1 in negative direction means m is less than minus 1. So this is the about the image of in the case of spherical mirror, right? Last, fifth. So you are finally moving the image object towards pole and your image is moving away from the pole, right? So what is happening in the last case, you can say, let's say the image is here at pole, sorry, at focus, this is image is here, so it will go parallel, after reflection it will pass through this one, anything coming here, after reflection it will go like this way. So we'll say this will become parallel, right? If I have the proper draw करने के लिए ठीक से चीजें मौजूद हो, so I can tell you that it will go parallel, I can prove you, but just try to understand that when the image object will be at focus, the reflected rays will become parallel. So it means size of image will be too much, right? Enlarged, it will become too much, right? Enlarged, so it will appear that somewhere it is going to intersect at infinity, right? They are just going to infinity. Inverted, है ना? Inverted, where it is focusing at infinity. At infinity means it will be formed at very distant, at a larger distance. Inverted, it will be a very big image, right? and the second thing is in magnification will be m will be less than minus 1 say मतलब m will be greater than 1 greater than 1 but in the negative direction, so you can say m will be less than one, this one same thing, that will tend to infinity basically magnification. And inverted हो गया, inverted real, right? The image will be real because it is going infinity, it is not diverging, it is believed that somewhere it will intersect, right? So this will be the fifth case. Now the last case is number 6. This is the mirror. This is focus, this is center of curvature. Now the image is in between focus and pole, right? So light ray will be traveling which direction? This way, coming parallel after reflection pass through focus. Let's say it coming this way, it will go this way. So you can say here in this case the light ray will diverge in nature, they are just distance is increasing, so basically they are diverging in nature, so they will never intersect here. Never intersect means first thing is virtual image will be formed, virtual image will be formed. So when you move it back, it appears like both the rays, both the lights, both the reflected rays are intersecting here. It appears like this. It is not really intersecting, but it appears someone standing here, let's say someone has eye here and she is watching, he or she is watching here, so it will be assumed that the light rays are coming from here. It means it is believed that the two reflected rays are coming from here. So what does it mean? The virtual image and it will be erect image, right? So first case in the concave mirror where the image is erect. Second, the first case where the image is behind the mirror. First case where the image is virtual image. First case where the magnification is greater than 1, positive, right? Positive. So these are the, and virtual image, these are the properties for spherical mirror image formation. So important thing is you can अच्छा एक मिनट, I'll write object image, right? Object is at infinity, image is at focus. Object is between infinity and C, image is at between C and F. Object is at C, image is at C. Object is in between C and F, image is between infinity and C. Object is at focus, image is at infinity. Object is at object is between, I will write here, between focus and pole, so object is, image is behind mirror. So this you have to remember, right? This you have to remember. So please try to understand this in detail. This is the thing which you have to remember, and let us move in the next mirror, that is convex mirror, right? So I hope you understood it. Convex mirror. So image formation is at convex mirror. मतलब let's say I'll tell application, I'll tell you later. Number 1, convex mirror में let's say you have this mirror. This is the image. Sorry, this is the polishing. And let's say image is here. Sorry, object is here. Let's say object is here. This is A and this is B. So a light of ray is coming here. It will come after reflection. It will tend to pass through focus. So this is the focus. It will try to pass through here, but it cannot pass. So we will trace it in the reverse direction. Let's say a ray of light passing through focus. Let's say it's directly going to focus. So it is going to focus. So after reflection, it will become parallel this way, right? So you can say both ray of light are diverging. Both ray of light are diverging. See, this is diverging, right? Both ray of light are diverging. So basically, when you will extend it, so they are intersecting here. So means image will be formed here, right? So matlab here there is only one case. In this case, object is where? Object is between infinity and p, anywhere. Sorry. Image will be between pole and focus. Nature of image is erect, diminished, small in size. Magnification is positive and less than 1. So this is the important thing. So the application is very important. They may you, I'm just giving you homework to remember the more application of convex and concave mirror, because question may come ki doctors, ENT, eye, nose and teeth doctors are there. They use the mirror, right? Either they can use convex mirror if they want a smaller size of picture, or they can use the concave mirror, but they will have to place the mirror such that the distance object is between pole and focus, so that the image will be inverted, sorry, image will be erect. So this is the application of convex and concave mirror, right? So just try to remember these things in detail. Mirror के लिए in the today's class I'll be discussing about the mirror only. In the next class we'll be discussing about the ray optics, right? So here what we will do, there is one very important thing, like number of images. First let me discuss number of images, then I will discuss the mirror formula. So number of images concept is there. Let's say you have two plane mirrors. It is possible only for plane mirrors. Let's say you have two plane mirrors like this, okay, and they are placed at angle theta. So how many image will be formed, right? So you have to, what you have to do for number of angles, you have to calculate 360 by theta. Find 360 by theta, which is m. So number one is find 360 by theta, which is number one, right? Case 1, number 2 में you can say case 1, if m is even, if m is even, then your number of image will be m minus 1. Case 2, if m is odd, if m is odd and the image is placed symmetrically, matlab let's say this is the placement and you are placing the image at the symmetric position, let's say at this point, such that at the symmetric, the object is at symmetric position with respect to both mirrors, then in that case matlab object is placed at symmetric location, then number of image will be same m minus 1, right? And second thing is, if asymmetric, what is asymmetric? Means object is placed at asymmetric position, let's say object is placed somewhere here, right? So in that case your number of image will be m. So generally the second case is considered if nothing is given, right? So this you will have to remember. Next thing is, guys, very important, mirror formula, which is used for spherical and plane mirror. Mirror formula. Mirror formula is 1 upon v plus 1 upon u is equal to 1 upon f, where v is the distance of image from mirror, u is distance of object from mirror, and f is focal distance, yeah, focus of mirror. Focus of mirror. So while using this formula, you have to follow the sign convention. You have to follow the sign convention. So let us try to understand the sign convention. What is sign convention? So see, this is, let's say, mirror. Let's consider about this one, right? This is your spherical mirror, and this is your pole. So consider pole as origin. So in, let's say your image is, object is here. So object is in the left direction, right? So u will be negative in this case. Where is focus? Focus will be also will to the left. So f will also be taken as negative. Let's say image is formed here. Let's say this is the image. Let's say this is image. If image is formed here, then this will also be v. So v will be also negative in this case. Let's say mirror is this way, and such that your object is placed here and your image is formed here. So in this case, u will be negative, focus will be negative, but v will be positive because it is right to the origin. Origin matlab pole, right? Second, let's say you have convex mirror. In convex mirror, like this one, focus will be in this direction, right? Center will be in this direction. So it means, let's say object is placed here and the image is formed here. So this is u. So u is negative. Image is formed to the right, so image is, v is positive. Focus is here, so focus will be positive. So in the convex mirror, focal length is positive. In the concave mirror, focal length is negative. So this is the sign convention, guys. You have to use it. There is one important concept more in the spherical mirror, that is spherical aberration. Spherical aberration is what? This is important concept. See, spherical aberration, right? Spherical aberration is the inability, right? Is the inability of the mirror. It is a type of defect, right? Inability of mirror to converge the parallel rays at focus. Matlab, let's say you have this mirror, right? And the light rays are coming here. This is focusing it here. But let's say another line is coming here. It is focusing it here. So let's say it is not able to focus at only one point. So let's say there is some defect. So this error will be known as spherical aberration. Now your challenge is to find the ways how to remove this spherical aberration in the mirrors, right? Just find it and remember it and note it. इसको याद कर लेना अच्छे से. So spherical aberration, this is the important thing. I hope this is clear to you. The spherical, the basic concept of the ray optics, the first lecture of the ray optics. In the next lecture, we will have to discuss the Fermat's principle, Vibgyor, lateral shift, normal shift, total internal reflection, Cauchy's relation, circle of illumination, application of TIR. In the next lecture, your prism and dispersion. And in the same lecture, we can cover if human eye and power of lens. So these are the things left in power in the ray optics. After that, we'll study wave optics. So see you in the next video, guys. Till then, bye bye.